Section 7.4, periodic graphs and phase shifts. Our objectives are to state the period, amplitude, vertical shift, and phase shift for the given function, rule, or graph of a sine or cosine graph, and then eventually we will be graphing these. The distance that one graph must be shifted to the right or left to coincide with another graph is called the phase shift. So it's really just a horizontal shift, it's just a different name for it. Consider the parent functions of sine and cosine. What phase shift would we need to make the cosine graph equal the sine graph? So let's go ahead and look at this graph right here. Before we get to that question I just asked, let's think about the sine of x plus 2 pi. Remember when we add 2 pi to our angles that we're really finding coterminal angles on our sine graph when we haven't changed the wavelength, because adding 2 pi or subtracting 2 pi gives you the same angle, same terminal side for your angle. Now for this, if we add 2 pi, that means, remember when it's adding, we're really moving our graph to the left 2 pi. So if I take all these values and I move them to the left 2 pi, that means this value here at 0 would move over here to negative 2 pi. This value of 1 would move right here, and so on. So if I actually just move that whole entire graph, notice that it still looks like a sine graph. The only difference is we just shifted it over. So that would be a phase shift of 2 pi to the left. Now, let's say that we wanted to make this into a cosine graph. Well, remember, cosine graphs normally start with a 0, 1. So if I shifted this graph to right there, notice that would give me a cosine graph. So how did I shift the sine graph? I had to shift the sine graph to the left pi over 2. So I know that the cosine of x would be equal to the sine graph shifted to the left pi over 2 units. And that's where we get that equation. And let's do the reverse. If I have the cosine graph, if I want to make it into a sine graph, I would have to shift it then to the right pi over 2, because I would have to go back this way right here. So if I have the sine graph is also equal to the cosine of x shifted to the right, so minus pi over 2. And that's how we can get those two equations. So that's helpful to kind of think about when we're doing these phase shifts. All right, going back. Now, combined transformations. For these combined transformations, this is the equation that we use, y equals a times the sine of b, and then t minus c over b plus d. Where does that c over b come from? So the actual equation we would use would be y equals a times the sine of b t minus c plus d. I believe that's how they write it in your book. But remember that that c that's written like that, if it didn't factor out that b value, is not really your phase shift. In order to get your phase shift, you have to factor out that b value that's in front. So how do you do it? You divide it out, and when you do that, you get these equations right over here with the c minus c over b. So that c over b is really your phase shift. And I don't always write the equation with a minus c over b. Instead, you'll see me write the equation as y equals a times the sine of b times t minus c plus d. So instead of writing c over b as my phase shift, I'm going to usually write the c value right here as my phase shift that I have. So just as a reminder, remember the period is the distance horizontally that it takes to complete one wavelength on your graph, and remember distance is always positive. And the amplitude, remember, is the again, halfway distance in between the max and min values. And so remember amplitude, since it's again the distance that you're oscillating back and forth between wherever your x-axis is or where it's shifted to, it's a positive value. So that's where we get the amplitude is equal to the absolute value of a. We talked about the period of the function. When you're finding the new period, if you know your b value, given an equation, you can do your parent graph period, which for sine or cosine is 2 pi divided by b. If it's tangent or cotangent, then of course it would be pi. To find the phase shift, I'm just going to call it right now your c value using this equation. If you use this equation up here, your phase shift would be the c over b. And of course, your vertical shift is the d value. Those are things we've talked about before. So I'm going to give you guys some helpful hints in order to help you find some of these values. So the amplitude, notice that it's changing your y values. So in order to find it, we said before, we do the y maximum value minus the y minimum, again, that just means using your y-coordinate of your max or min points, divided by 2, that gives you your amplitude. We already talked about the b value is 2 pi divided by the period. So we just took the equation that we did up here and cross-multiplied and solved. Your c value, which is your phase shift for a sine graph, you do the x maximum. And if you take the maximum and add it to the minimum, and divide it by 2, that's going to give you the average of the 2 points, so you the midway point in between your max and min values. And when you do that, you would get this value in between. So if we took our maximum and our minimum and divided by 2, that gives you that middle value, so like the average in between. And your d value is going to be your maximum, so your y maximum plus your y minimum and divided by 2 to give you your vertical shift that we have. So let's go ahead and do some examples of this. Determine the period, amplitude, vertical shift, phase shift, and key points for the graph of the given equation. So the amplitude, of course, is just the absolute value of the number in front of your sign. So remember, y equals a, so that's our a value times the sign. And then, of course, we have b times t minus c plus d. So my amplitude a is the a value, the absolute value of 1/3, which is equal to just 1/3. So that gives me the amplitude of my equation. My period of my equation, to find it, I use the fact that I know my b value is equal to, in this case, we don't use -2, just use 2. So the b value is equal to 2. Because of that, the period is equal to your parent graph period, which is 2 pi divided by your b value. So in this case, 2 pi divided by 2 equals pi. So that gives me the period for the equation. My phase shift, if I want to find it, first I have to factor out my equation. So when I factor out my equation, b value, I get y is equal to 1/3 times the sine of -2, which I'm factoring out, t, and then minus minus would become plus 5/2. When you're factoring out, you're really just dividing it out. So that gives me a phase shift, and usually I do PS for phase shift, so if you see me write that, that just means phase shift. So the phase shift in this case, or if you want to write your C value, would be equal to, we're moving it to the left 5/2 because it's plus 5/2, and notice your equation is normally minus, so it's going to be minus 5/2, so that moves it to the left. And your vertical shift, of course, there is no D value, so there is none, or 0 if you want to write. And your key points, how do you find those? You take the period of your function, which in this case is pi, and you divide it into 4 equal parts or multiply it by 1/4. So my key points would be equal to pi over 4. So being able to do all of this given an equation is important because this is going to help us graph these equations that we have. So make sure that you can do that. The next thing we're going to do is we want to, given a graph, be able to come up with the rule for the equation. And for this, we're going to challenge ourselves to write both a sine and a cosine graph. So I always like to write down the equations because it helps me kind of figure out what I need to find. So the easiest thing to find first is usually your amplitude and your vertical shift using your max and min values. So I know that I have a maximum right here and a minimum right there. So in this case, if I want to find my A value, again, remember it's your maximum minus your minimum divided by 2. So in this case, my Y maximum would be 2, and my minimum would be -2, so minus -2 divided by 2 gives me 4/2, which is just 2. So I know my amplitude is 2. My vertical shift is your maximum plus your minimum divided by 2. So in this case, 2 plus -2/2 gives me 0/2, and 0 divided by 2 is just 0. So there is no vertical shift. It's helpful to know that there's no vertical shift because that means that I can easily figure out what kind of graph this looks like first. The easiest one to be would probably be a cosine graph because it's not starting at the y-axis on 0, 0. So if I start off with a cosine graph, I notice that I have this distance from here to here. So because that's the distance from there for a cosine graph that would have been reflected over the x-axis, it's easy to figure out then what your period would be, because I need to figure out the distance from here to here. So this horizontal distance right there. Well, looking at my graph, it's not easy to tell that distance, because if I erase this point right here, notice it's not on that tick mark that we have, and we're going from 0 to 2 pi given this graph when we're looking at it on this plane. So how can I find that distance to be sure that I'm getting an accurate distance? You can use your max and min value points. So if I find the distance from here to here, then that's half my wavelength, and if I multiply that by 2, I can go ahead and figure out what my length of my period is. So notice that we have -2 and 2, or sorry, our x values, so 2 to 4. So the distance from 2 to 4, of course, if you do 4 minus 2, the distance is 2. So if the distance from here to here, which is half my graph, is 2, well, then the whole distance would be a one wavelength of 4. So that gives me the period of my graph to complete one wavelength. So if that's the period, then we can figure out our b value by using our equations. So my b value is equal to my parent graph period, 2 pi, divided by the new period, which in this case is 4. So my b value would be pi over 2. And again, we know that a vertical shift is 0. The only thing we have to figure out is a phase shift. So for this first one, I don't have to shift it left or right at all, because it's already on the y-axis. All I have to do is reflect it. So one equation that I can write for a cosine graph would be y equals the -2, so your amplitude would be negative in front because it's a reflection, times the cosine of my b value, which is pi over 2 times t, or you can use x, doesn't matter, plus 0. So that would be one equation. Well, let's say that instead of having to do a reflection for my graph, that I want to do a cosine graph that would be positive in front. So if that's the case, well then remember that our cosine graph normally starts over here, and this would be a cosine graph that has an amplitude that I just moved it, so an amplitude of 2. So in order to go from my cosine graph over to here, well, how did I shift that cosine graph? Well, I'm shifting it to the right, whatever value from here to here is. Well, if that local maximum is 2 comma 2, well, then the distance from here to here is your x value, which would be a distance of, in this case, 2. So I would have to move my graph, my graph to the right 2 in order to get that. So another graph that I could do would be y equals 2 times the cosine of pi over 2, and make sure that's factored out, times x minus 2, because I'd have to move my cosine graph to shift it into this new equation graph to the right 2, and then there's no vertical shift. So that would be another equation. Now, the sine graph for this one is a little bit harder, because the sine graph, if you'll notice, is we have to figure out what the point would be for a sine graph. So now for a sine graph, if I erase this here, the point we're looking for is where it's crossing on my x-axis. So if you have a vertical shift, you look for wherever it's shifted to on that new x-axis that you would have. So here would start a sine graph, because that's where it crosses my vertical shift, in this case, which is 0. And then I know one wavelength for sine goes up and then down and looks like that. So if I want to come up with the equation for this, well, a sine graph normally starts here. And if my sine graph normally starts here, well, how did I shift it into this new graph? I had to shift it over this distance from here to here. So the horizontal distance that starts from here to here is what I need to figure out. Well, the question is, how do I figure out what that distance is? I need to figure out what my key points are going by on my graph. Well, if my period is 4, then my key points would be going by 4 divided by 4, which is 1. So I know that this value right here is at 1. I know that this value here is at 2. This one that I'm crossing next right here actually is 3. It's not by the pi, it's a little bit in front of the pi. And then this one right here would be, of course, 4. So that shift that I'm shifting my graph is a value of 1. So with that, and of course I'm moving it to the right 1 in order to get my new graph. So my equation that I could use would be y equals, and of course my graph is going up first, so it's positive 2 value. So 2 times the sine of my b value, pi over 2, times x minus 1. That would be one equation. Do I have to use that equation? No. I could use this value over here if I wanted to and shift my graph. So if I started here, I'd have to shift my graph to the left, whatever this distance is right here, which would be -1 to -3. So I could use that value right there. I knew it was -3, or not -3, -1, yeah, -3, it looks like. So if I could use that for my distance, I'm just using the period to help me find that value. Or let's say that I didn't want to use this value here. Let's say that I wanted to use the value at 3 right here. If I use that value at 3, well then notice that if I shifted my graph from here to here, my graph would be going down first. So another equation that I could have is y equals -2 times the sine of pi over 2 times x minus 3. So there's a lot of different equations that we can come up with this. So normally we try to pick the first place that's closest to the y-axis that would make our graph a positive sine graph or a positive cosine graph. So that's usually what you're going to see when I'm doing these equations. So you just, again, look to see what gives you the first positive sine or cosine graph without any reflections. But if you want to make some with reflections, that's fine too. So now let's go ahead and look at number 2. So I challenge you guys to maybe see if you can write 2 equations on your own. So I'd pause the video and then see if you can check your answer with what we have. So again, the first thing I want to do is find the amplitude. So the amplitude is going to be, in this case, my maximum y value, which is 9, minus my minimum, which is -3, divided by 2. So 12 over 2 would give me 6. So if the amplitude is 6, I can count on my graph 1, 2, 3, 4, 5, 6 right here. And if I count down 1, 2, 3, 4, 5, 6, it should be the same. That tells me that I know I'm going to have a vertical shift to this place right here. So you can do that for your vertical shift, or again, you can just calculate it using your maximum plus your minimum divided by 2. And 6 divided by 2 is 3, so your vertical shift in this case is 3, which is what we're showing right here in our graph. Then I need to figure out the wavelength of this graph, so I can do what I did in the last graph. If I look, I can see that I have a maximum. If I know my x values, it's easy, just take that distance and multiply it by 2. So this looks like a cosine graph from here to here, which would be easy to use. So I know that this x value here, and I know this x value, so if I figure out half the distance, again, I can multiply it by 2. So the distance from here to here would be 2.5 minus 0.5, so the distance is 2. So that means that 2 times 2 would give me the whole wavelength. So the period of this function is actually equal to 4, just like the last one. So if the period is 4, just like we found in the last one, then our b value is going to be 2 pi divided by 4, which in this case would be, again, pi over 2. Now for that, if I want to make a cosine graph, well, notice this one's a little bit harder because unlike the last problem that we just did, it's not right on the y-axis for my cosine graph. Notice I have a shift. So if I take this minimum value that I have down here, I'm shifting it to the right. It looks like whatever that distance is, so that distance is 0.5. And if I shift it to the right 0.5, then notice my graph would be opening downwards first, so I'd have to have a reflection. And it's easy to use that value because that was the value that was given to me, that 0.5. So if I do one equation, I could have y equals, in this case it would be negative, and the amplitude we said is 6, so -6 times the cosine of my b value, pi over 2 times x minus 0.5 plus my vertical shift, which would be 3. So that would be one equation. But remember I said usually use the positive distance. So if I did a positive cosine graph, it would start up here like this. So I'd have to shift it over 2.5 to get here from a normal cosine graph. So we vertically stretched our graph by 6, and then we shifted it up 3, and then we'd have to move it to the right 2.5. So another equation that you could have would be for cosine y equals 6 times the cosine of pi over 2 times x, and then since it's moving to the right, minus 2.5 or 3/2 plus 3. So that would give me another cosine graph. Of course, there are other graphs that we can come up with too. Now let's talk about finding a sine graph. So this one's a little bit more difficult in order to find a sine graph. For the sine graph, I look at where it crosses my new x-axis, and I'm looking for somewhere that's going to go up first. So right here, it looks like. So from here to here would be a sine graph. So I need to figure out, well, normally again, we start down here for our sine graph and we stretched it up by 6, and then we moved it vertically up 3 units, and then I shifted it this distance from here to here. Well, the question is, what is that distance? I know the x value distance here, and I know this x value distance there. So in order to find the distance for a sine graph, we'll notice that sine is always going to be the average or in the middle of your maximum minimum values for x. So if we take our x values, so 2.5 from my maximum value, and add it 2.5 and divide it by 3. Well, 2.5 plus 0.5 divided, not by 3, sorry, by 2, so we're taking the average, would give me 3 over 2. So that would be 1.5, so that's the value that I can use. So if I shift this graph over, this little distance right here to here would be 1.5 to get to that point. So, and I would have a sine graph that would be positive because it's going up first. So y equals 6 times the sine of my b value, pi over 2 times x, and we're moving it to the right, so minus 3/2, and then plus my vertical shift. And I think before the negative 2.5 I said 3/2, but I meant 5/2 if I said that. So for the negative 2.5. Now, did I have to use that for a sine graph? No. Of course, I could have used this right here for my sine graph. If I did that right there, then I would have to figure out what this point is, and I can do that by using my key points in order to help me, because I know my key points are going by a value of 1. But it's harder to tell on this graph because it's not exactly on the key points, so I usually just use the values that they give me just to make sure. But if I did it from here, then that would be shifting my sine graph to the left, whatever the distance is from here to that blue dot right there, and then I would have another sine graph. So that would be another possibility. Could I have used the sine graph that would start right here if I knew what this distance from here to here was? Yes, that would be another one. So that would move it left that distance. But again, usually we pick the first place where it's positive closest to the y-axis for our sine or cosine graphs. That's what usually makes these graphs so difficult, is that we have so many different places that we can pick these equations for. All right, so this is the last graph that we're going to do. For this last graph, maybe challenge yourself to see if you can figure out what the equations would be before you do it by hitting pause. Now, if I look at these graphs, I can tell that either this is going to be a tangent graph or a cotangent graph. So the first one in my head, when I look at it, I'd probably say it looks like a, since it's shifted over and it's going up to the right, a tangent graph with the shift. So for this graph, if I look at it, the amplitude, remember for tangent, we don't have one. So then usually just look at the values in between here and here to look to see where it's at. So notice that value here is at 1 and this one's at -1, which tells me I don't have a vertical shift. So my a value for tangent is going to be 1. Now the period of the graph is the distance it takes to make one cycle. So from here to here, because we have an asymptote to an asymptote is what you're really looking at, would be pi over 4. And if I want to figure out the b value, then remember the b value is equal to your period of your parent graph, which in this case is cotangent or tangent. So pi over your period. So pi divided by pi over 4 would be the same thing as 4 over pi, which is equal to 4. So that's my b value that I'm using. And if you wanted to figure out your key points, you would just multiply your period by 1/4 because you're dividing in 4 equal parts. So your key points would be equal to pi over 16. So this is that value right there. So 1 pi over 16, this would be 2 pi over 16, 3 pi over 16, and 4 pi over 16, which gives us pi over 4. So that's the way that you'd find that. And then the last thing I want to figure out is if I have a vertical shift. Well, if this is point right here, that's the middle point in between my asymptotes is on the x-axis, I can tell that I don't have a vertical shift. That's what I would use to look at it. So in this case, the vertical shift would be none. So if I do this graph as a cotangent graph, well, cotangent graphs, remember, usually start up going this way and down. So in this case, I wouldn't have a vertical shift if it was a cotangent graph. I would just have a reflection. So y equals negative cotangent of my b value, which is pi over, no, my b value, which is 4 times x, and there is no vertical shift. So that would give me my cotangent graph. If this was a tangent graph, then for my tangent graph, remember your tangent graph normally starts at 0 and would look like this, and your asymptotes would be here. So how did we shift this graph? We shifted it over, it looks like a distance from here to here of pi over 8 because we moved it from here to this value right here. So if we shifted that a distance of pi over 8, I'm just going to draw it in so you guys can see. So if I lift this up, we shifted it from here to there. And of course, that distance from here to here is pi over 8 because I'm just moving it from 0 to there. So then it would be a tangent graph, y equals the tangent of my b value, and then parentheses x minus pi over 8. And again, there is no vertical shift. So this would give me my tangent graph. So these are two equations that you could have. Of course, there are other equations. We could have had a shift if I moved my tangent graph from here to here. Of course, then we're moving our graph to the left. So if we move my graph to the left, instead of minus pi over 8, another graph that I could have had would have been just changing this to a plus pi over 8, and it gives you the same thing.